Hello students, I hope you all are fine. Students, today we are going to discuss about the topic Arrhenius theory. Okay, this is the topic of the unit 3 of class 12th. The unit is chemical kinetics. Okay, so students, Arrhenius theory, it tells us about the effect of temperature, or we can say it tells us about the dependence of temperature of rate of the reaction. Dependence of temperature of rate of reaction means how does temperature affect the rate of any reaction. It is told by the Arrhenius equation, Arrhenius theory. Arrhenius was one Swedish chemist. He told us that if we want to make the product, then reactants will collide with each other. Reactants will collide with each other. But that collision should be effective. That collision should be effective. If effective collision will be there, only in that condition we can get the product, otherwise not. Okay, so students, some basic terms we need to require here. First one is the threshold energy. Threshold energy. First of all, we will see about some basic terms related to this. Threshold energy. Threshold energy is that minimum amount of energy that minimum amount of energy required by reactants for making collision effective, or we can say for getting product. Arrhenius has said that when reactant will collide with one another, but they should collide with a efficient amount of energy. Okay, then they can give just product, and the minimum energy which is required by the reactant for making the collision effective, that amount of energy is known as the threshold energy. Okay students, but if reactant is not having the sufficient amount of energy, then what it will do? It will absorb from anywhere. We need to provide heat, we need to provide energy in form of heat, in form of light, in form of electricity. Means reactant first absorb some amount of energy, then it become activate. Okay, so students, if reactant is not having sufficient amount of energy, then it will absorb some amount of energy, and that amount of energy is known as the activation energy. So what do you mean by the activation energy? Activation energy is the amount of energy absorbed by an reactant. Okay, for forming activated complex. Okay, Just try to understand with the help of the diagram. Students, let us consider we are making one graph. We are making one graph between the potential energy. This is the potential energy. Versus progress of reaction. Progress of reaction. Just try to understand. Let us consider we want to do reaction and this is energy. So this is the energy of reactant. Means reactants are having this energy level. But student, for activated them, for activation, they need this amount of energy. Let us consider that is the minimum amount of energy which is required for making the collision effective. Means this is the threshold energy. Threshold energy. Minimum this amount should be there, then we can get product, otherwise not. For example, if you want to make tea, so student, for making tea you need water, you need sugar, you need tea leaves. Okay, means the water you are having, milk you are having, they are not at zero temperature. At least room temperature they are having. Means they are having some temperature. They are having some energy. But student, that amount of energy is not sufficient for making tea. If we will mix water, we mix milk, we mix tea leaves in them, and we mix sugar, and we put it into the sunlight, then will you able to make the tea? No. Because for making the tea, a sufficient amount of energy it needs. And that minimum amount of energy which is required for making the collision effective, which is required for making the activated complex, that is known as the threshold energy. Means first of all, minimum energy it required at which it may be activated. Okay, so means that is the energy which reactants are having, but that energy is not sufficient for giving product us. Okay, then it will absorb some amount of energy for become activated. Okay, so this amount of energy which is absorbed by the reactant for becoming equal to the threshold energy. This amount of energy is known as the activated energy, or we can say activation energy. And activation energy, students, you can represent by EA. Okay, now all reactants are activated. All reactants are activated. Then they will start to form product, and finally we can get product. Let us consider you are getting product at this energy level. So this is known as the energy of product. Energy of product. Why I am showing in this way? Student, try to understand. Let us consider you are having two molecules of hydrogen iodide. If you provide heat it, then it will decompose into H2 and I2. How does reaction take place? Reaction take place in two steps. Okay, first of all, this is one molecule of HI, hydrogen iodide, and this one is the second molecule of the hydrogen iodide. Yes or not? Yes. Then students, if we want to make hydrogen molecule and iodine molecule, then first of all, we need to break bond between this hydrogen and iodine. We need to break bond between this hydrogen and iodine. First of all, old bond will break. Old bond will lose. They get loose. They will start to break. Okay. After that, new bonds will start to form. New bonds will start to form. And at this state, when old bonds start to break and new bonds start to form, that is known as the activated complex. That is known as the activated complex. So students, first of all, old bonds will become loose. They will break. And for breaking anything, we need to provide some amount of energy. Means first it will absorb the energy. And if energy is absorbing, then at that time it is endothermic. Okay. When they get loosened completely, means they get removed, they get breaked completely, then new bonds will start to form. Means now, if these molecules will collide, they will come closer to each other, then they can form new product. Yes or not? Yes. So student, when they will collide, so after collision, they will produce heat. They will produce energy. So at that time, this process is exothermic. That process is exothermic. So if amount of energy absorbed is less than amount of energy released, then this reaction is known as the exothermic. Exothermic. So here you can see this is the graph for exothermic process, because this is the energy absorbed, but this is the energy released. So amount of energy released is greater as compared to the amount of energy absorbed. That's why it is the exothermic process. Okay. And how can we calculate change in enthalpy? Students, enthalpy change, we can calculate del H is equal to enthalpy of forward minus enthalpy of backward. Okay, so forward reaction is takes place from here to here. So this is the forward, and backward, it is taking place from here to here. So this is backward. So you can see amount of backward is greater as compared to forward. So overall you will get negative value. So for exothermic process, del H will be the negative. Del H will be the negative. So student, here you can see, let us consider this. This is the energy of reactant. Means two reactants you are having, two molecules of hydrogen iodide you are having. Let us consider this is the amount of energy possessed by the hydrogen iodide. So that is known as the energy of reactant. But that amount of energy is not sufficient for making the product. Okay, so it need to absorb some more amount of energy for become activated. So this is absorbing this amount of energy, and it is known as the activation energy. It is known as the activation energy. Okay, so this amount of energy is the minimum energy which is required for making the collision effective, and it is known as the threshold energy. Okay, so we can say reactant energy plus activation energy will be equal to the threshold energy. Okay, I hope it is clear to you. Then after breaking the old bond, it start to form new bonds. So it will release the energy. So finally, let us consider we are getting the product at this energy level. So this is known as the energy of the product. Clear? So if this for backward energy level is greater as compared to forward, then it is known as the exothermic process and enthalpy change will be negative here. And in other way, this is potential energy. Progress of reaction. If same graph you want to make for the endothermic process, then how will you do? In same way, if this is the energy of reactant, but for become activated, let us consider it need this amount of energy. So this minimum energy required for making effective collision, it is known as the threshold energy. So for making effective collision, it need this amount of energy more that is absorbed by the reactant. That is known as the activation energy. That is known as the activation energy. So first of all, it is forward reaction. In forward, it will absorb the reaction. Let us consider after becoming activated complex, it will release some amount of energy. It will release some amount of the energy and finally it will form product. Let us consider at this energy level, it is giving us product and that energy level is the EP, energy of product. Now you can see, this is the backward reaction. This is the backward reaction. So here you can see, del H will be E forward minus E backward. So you can see, E forward is greater as compared to E backward. So del H will be the positive here. Del H will be the positive here. And this amount of energy is energy absorbed by that. And this amount of energy is energy released by that. So you can see graphically, absorbed energy is greater as compared to the released amount of energy. So the reaction, the process in which energy is absorbed, that is known as the endothermic reaction. Okay. So students, this graph is for endothermic process. For endothermic process. I hope this is clear to you. For endothermic, this graph, and for exothermic, this is the graph. Then students, we will discuss about one more term, that is the most probable speed or kinetic energy. Actually, if we increase the temperature, then student, what will happen? The more part of amount, mean maximum, or simply we can say if you will increase the temperature, then kinetic energy will increase. And if kinetic energy will increase, then most number of particles can take part in reaction. Okay. So students, from here you can See, if we will increase the temperature, because kinetic energy is going to increase, that's why most number of particles are going to take part in reaction. So we can say a rate of reaction will increase. Rate of reaction will increase. Rate of reaction will increase. Okay, so in this way, Boltzmann gives one curve, gives us curve. What about the curve? He draw the graph between number of collisions and kinetic energy. And kinetic energy. Let us consider this is the curve at time t. At time t. And this is the curve at time t plus 10. T plus 10 degree. So students, what do you mean by this peak? What do you mean by this peak? This peak means most part of the particles, most part of particles is having that amount of kinetic energy. Is having that amount of kinetic energy. Means that is known as the most probable kinetic energy and most probable state. Yes or no? Yes. So students, now we will discuss about the Arrhenius equation. Arrhenius gave us one equation. The equation was Arrhenius equation. Arrhenius gave us equation, and equation was K is equal to A E minus EA by RT. This equation is showing dependence of the temperature of rate of the reaction. Okay, so what is K here? K is the rate constant. K is the rate constant. A is the Arrhenius constant. It is also known as frequency factor. Frequency factor. And students, it is also known as the pre-exponential factor. Pre-exponential factor. You will keep in mind all three names because it is most important for exam point of view. Okay, so it is known by three names. One is Arrhenius constant because it was given by the Arrhenius. Frequency factor because it is telling us about number of collision, means how much time it collide with each other. And because before exponent we are using it, that's why it is also known as the pre-exponential factor. So you will learn all three names for this. Then student, this E is the exponential. EA is the activation energy, and already I told about the activation energy. Activation energy is that amount of energy which is absorbed by a reactant for becoming equal to the threshold energy. Okay, then this r is the gas constant, and I hope you all know about the value of gas constant. Okay, it is 8.314 joule per Kelvin per mole. You will keep in your mind this value also, because you need this value in numerical portion, so you need to learn this one. Okay, because it is a constant value, it will not change. Then T, student, T is the temperature. T is the temperature. And if I talk about this term combinedly, this term combinedly, E minus EA by RT, then it is known as the Boltzmann factor. Boltzmann factor. Okay, means most part of the particle having kinetic energy greater than its activation energy. Is it clear or not? Again, I am going to repeat. Most part of the particle is having kinetic energy greater than the activation energy. First thing, students, you all will learn about them. What is K here, what is A, what is EA, what is R, and what is this factor. You will learn about them. Then student, how does it show the dependence of the temperature? Let's see about that. So what was the equation? Equation was K is equal to A E minus EA by RT. First of all, take logarithm both sides. You will take logarithm both sides. Okay. So here ln K is equal to, here's ln A e raised to power EA by RT. So student, you can write in this way ln A, because if in multiplication they are, because this is the formula, ln A plus ln B is equal to ln A into B. This is the formula. Okay, by using this you can learn ln A plus ln E minus EA by RT. Then students, log and exponential, they cancel each other because it is anti-log. Logarithm and anti-logarithm, they will cancel each other. So ln K is equal to ln A minus EA by RT. EA by RT. So if temperature is T1, then K will be K1. So how can you write this equation? You can write the equation in this way. ln K1 is equal to ln A, this is the constant, minus EA by R T1, because EA is also constant, R is also constant, T is varying, temperature is going to be vary. Then ln K2, if temperature is T2, then K will be equal to the K2. You know very well, na? Rate constant is temperature dependent. If for the same reaction, you are going to change the temperature of any reaction, then rate constant value will also vary there. Okay. Then students, if temperature is T1, so we are considering constant is K2, but this constant will remain same here, minus EA by R T2. Clear? Then let us consider this is 1 and this is the 2. Then subtract 1 from 2. 1 from 2. So second is ln K2 minus ln K1. Left hand side you will subtract from left hand side and right hand side you will subtract from right side, is equal to ln A minus EA by R T2 minus A H ln A. If we are doing subtraction, okay, so it was in plus, now it will be in minus. It was in minus, so sign change take place, now it is in plus. EA by R T1, okay. LNA, they can cancel each other, okay. And student, this was also formula. In first order reaction, I already told you about that formula. Log A minus log B, I can write equal to log A by B. Log A by B. And log A plus log B, I can write in log A into B. Log A into B. And if you are having log A raised to power B, then it is equal to B log A. B log A. So you will follow these three formulas in our chemical kinetics unit in zero order, first order and in Arrhenius equation. So you will keep in mind about these formulas. Okay. Then students, we are following this one formula here, this one. Then ln, I can write K2 by K1. K2 by K1 is equal to here EA by RT1 minus EA by RT2. EA by RT2. Okay. We will solve it. What was the equation? ln K2 by K1 is equal to EA by RT1 minus EA by RT2. Same equation I have written here. Now, ln K2 by K1 is equal to EA by R. EA by R. It's common in both. Sorry for that. So it's common in both. So you will take common EA by R. EA by R. Okay. So from here you will get 1 by T1 minus. From here you will get 1 by 2. Yes or not? Just calculation part it is. You can calculate. You will take LCM. What will be LCM here? T1, T2. From here, T2 minus T1. So students, you will get this equation. And this is showing the dependence of temperature on the rate of reaction. And you will get numerical based on this in your exam also. Then students, in one more way you can get, in first order already I told you ln. ln is the natural logarithm. It will be equal to 2.303 log base 10. Log base 10. Then you can put the value. Here ln is 2.303 log K2 by K1 is equal to EA by R into T2 minus T1 by T2. Yes or not? T1, T2. Then students, log K2 by K1 is equal to EA by 2.303 R T2 minus T1 by T1 T2. So sometimes you can use this one also. You can use this one also. Both are the same thing. I just put the value of ln here. I just put the value of ln here. Okay. Then students, you can get graph also. You can make graph also by using this equation. How will you make? This is ln k is equal to ln a minus ea by rt minus ea by rt. So how will you draw the graph? What was the equation? Firstly, Arrhenius equation was this. After logarithm of both sides, you get in this way. Okay, so now compare this equation. What will you get? It is belonging to the I can write in this way also. Ln k is equal to minus ea by rt plus ln a. Then you can see belong it. You can compare with it now. Y is equal to mx plus c. Yes or not? And this is the equation of straight line. This is the equation of the straight line. Straight line. So how will you draw the graph? How? At y-axis you will take ln k. At y-axis you will take ln k. This is the y-axis. This is the x-axis. At y you will take ln k. Ln k. Then at x you will take 1 by t. You will take 1 by t. Okay. Then students, when temperature, 1 by t, it is 0. It is 0. Then what will happen? One constant value you will get, and that is the ln a. So let us consider this is ln a. Ln a. Because this is the equation of straight line. So straight line graph you will get, but slope is negative. Slope is negative here. So students, you will get graph in descending order. Clear? And here slope is minus m. Minus m is minus ea by r. Minus ea by r. Students, you got same type of graph in zero order also. You got same type of graph in first order also. And same graph in Arrhenius equation. But you need to keep difference in your mind. You will learn about the coordinates. Here coordinates are the different. Okay, graph is looking similar in all, but coordinates are different. So you will work on their coordinates. Clear or not? So students, this is all about the Arrhenius equation. I hope this is clear to you. So Arrhenius equation is telling us about dependence of the temperature on rate of the reaction. Okay, Arrhenius is telling us that when reactants will collide with each other, but they will collide with a sufficient amount of energy, and that minimum amount of energy is known as the threshold energy. In that condition they will provide us product, otherwise not, okay. And how does it affect? So with help of mathematical expression, with help of the graph also we have seen. I hope this topic is clear to you. So thank you, have a nice day.